Alright. Let's see what we can come up with this whole fill rate limit thing. So, last time I worked on this, I got to the point where I was able to render some SPH particles. Let's take a look at this. But what you'll see is that when I'm out here, it's pretty interactive. And I should note that while it is sampling a one-dimensional texture in order to get the exact SPH kernel correctly, there are some normalization issues I haven't really dealt with here. So let's reset the color bounds. You'll note that here it's getting pretty slow. I think, but I'm not sure, that some of this is related to a fill rate limit. So let's see if we can get around that. Let's also see if we can actually quantify that. So one way we could check on this is see what happens when we make our particle sizes a lot smaller. So we do this and you'll see, oh yeah, it's way more responsive. But as soon as we start increasing them so that they can be their full smoothing length size, it goes back to being pretty unresponsive. So let's try something here. I'm going to my vertex shader. Put this over here so that we can just recompile the shader when we need to. We recompile the shader. See, yep, okay, it's reflected there. What I'm going to try to do is I'm going to see if GL position dot x is less than -1. And GL position y is less than -1. Try doing GL position z equals -1. Okay, so here we're cutting out a whole bunch of them. Now, not all of them, mind you, but a lot of them. That seems to be having a big impact. So instead what we'll try doing is we'll say if v radius we will check to see whether or not the radius about the position is greater than our screen size. And if it is, we will not render it. So let's say vec2 left corner is projection times model view times position minus v radius. Say vec2 right corner. Oh, and this should be minus v radius. Position here. Let's see. Position is an input vector. Model vertex is we're actually looking for here. So model vertex in the new setup gives us each of our individual corners. And what we're doing here is we're doing projection times model view times position times v radius, the normalize of the inverse from the model vertex. So that's the key here. We've got our inverse, so we say the vec4 of modeled vertex, which will be minus 1, 1, whatever. So we do our inverse projection model view matrix times this in order to figure out what in world space would be the vector corresponding to that, corresponding to how we are translating by the correct amount. So we will see now if that puts us outside. Minus 1, minus 1. We'll say right corner, and this will be plus 1, plus 1. So now we'll say if left corner dot x is less than minus 1.0, or left corner dot y less than minus 1. And is less than minus 1.0, and our right corner is greater than 1.0, and our right corner y is greater than 1.0, then we're going to set our GL position.zw equals minus 1.0. That should dump it all the way out. And that should apply to all 4 vertices inside our triangle strip. And then here we'll just put all the rest of this inside an else. UV model vertex. Let's recompile our shader, see if we got any errors. It doesn't seem to be working. Oh, we did get some errors. Alright, let's see. Implicit cast from Vec4 to Vec2. Oh, yeah. Let's just make both of these Vec4. Okay, still getting some errors. Implicit cast from float to Vec2 on line 74. Oh. That doesn't seem to do too much. It has gotten a little bit better, but not a lot. So why don't we instead just make this Vec4. Let's see if no. Maybe we should try changing this clamp instead to a filter. Let's do that. So here, this is going to be this is going to be a Vec2. No, it's going to be a Vec4. Vec4 modified size equals projection that. Really what we want to do is we want to filter all this stuff out. So let's try instead. Get rid of these. So this is the tricky part. Basically my assertion here is that we are spending too much time rendering a whole bunch of triangle strips that are way too big. And that can happen because the particles are too close, too far. But in principle, we should be able to change this somewhat by looking at what the far plane is. So let's take a look at our camera. Now, this might not work, but we should be able to at least filter out a whole bunch of the particles that I assert are contributing. If I set sg.camera.farplane to be something much smaller. Right now, it's setting the far plane to be 20. So let's set the far plane to be 0.1. Now I changed the Python code, so I have to reload it. Interestingly, it's much more responsive when I zoom in, but you'll note that we're cutting out a whole bunch of particles. So let's try something. I want to add in our far plane editing. Let's see, render GUI. No. Let's see. I think it'll be inside Simple GUI. There we go, camera. One moment. I'll bring all these down when it's all done, okay? Okay. So let's add on here to our Simple GUI just a little bit of our camera info. So here we've got these hold trait notifications for attribute and position. Let's set mGUI dot float input float. The label is going to be near. Actually, let's do mGUI.text camera planes. Then we will do underscore comma values equals mGUI.input float 2. And here we will do scene.camera.nearPlane, scene.camera.farPlane, flags equals mGUI.input text turns true. Let's see if this works. Oops, I need a comma. So we look at the camera, we've got our camera planes. Interestingly, there seems to be something of a bug with the way that it's accessing these. Okay, changed equals changed for that. Dot camera dot plane. Our plane value is 1. Now I think we can do some formats here. So our formats are C style, so let's do, and these are unsafe, I will note. Or at least that's what the mGUI always lets us know. Format, oops. We'll do %0.3e. Let's see if that works. I forget how it works with C style format strings. I might need to do a G or something. Let's see if it crashes. Huh. Yeah, it's not even going out there. So let's just go back here. We'll be a little bit safer and we'll say format equals %0.6f. There we go. So there's our near plane and our far plane. Oh, and I've set the far plane here to be way too small, so let's change that. Oh, I have a viewer. Say hi if you want. Okay. Loading the particle index. It'll pull it up. Okay. So this is the entire scene again. You'll see we've got a far plane set to 20. Let's go zoom in a bit. Reset the color bounds. Now let's try changing our camera far plane. I changed it to 1. Got considerable, well, oh, because I'm inside the hold traits. I'm going to have to set the attributes, so let's do that. Set attribute scene.camera, near plane, value 0, far plane, values 1. Let's try again. Alright, let's see if this time I can change them. Yeah, it really seems like something's wrong with the way I'm doing IMGUI. Let's take a look at what the flags say. Let's just get rid of our yeah, that didn't do it either. Do I need to have some IMGUI begin and end stuff here? No, that seems like that just does a window. Am I inside a group or anything here? Is it because of a tree node? Let's get rid of our tree node. Oh. Gotta get rid of our tree pop too. something is definitely wrong with this. And I can't quite tell what the issue is, but seems like as good a time as any to dig into that. So let's see, we've got R equals a get attribute, scene camera attribute, mGUI text underscore values. So mGUI float 3. Okay. And then whenever I click, it seems to be selecting multiple. So why don't we try this? mGUI.begin group. mGUI. Core.begin group? No. Oh, and let's get back our tree node. This will lock the horizontal starting position. Alright, let's take another look at this, how the whole thing does it. So we've got mGUI new frame, changed as false. If scene is not none, it won't be. Sets the style, begins a scene. So here, let's, that's the window. Begin a group, end a group. Input float 3. Const car star label. So let's give it a label. Position. Gives it v3. I'm just going to go ahead and cast all of these explicitly to floats. That way we're at least making a copy of it. No, every time I click. It goes ahead. Selects everything else in there. I'm left wondering if this is somehow getting stuck on holding the trait notifications. And let's also take a look at what the available flags are. So where I'm looking right now is I'm looking at enter returns true. So we're going to go back to that. I think it's extra flags. Let me check. Nope, just flags. Equals mGUI dot input text enter returns true. We're going to do the same thing down here. For attribute in position up focus array equals get attribute scene.camera attribute, and let's also just go ahead and print it out. Oh wait, this is a good opportunity to, let's see, what is it, attribute equals, is that how we do it? The debug operator in F strings. And then array equals, should that do it? I think it might. So if we expand this, oh, another thing that's probably killing my processors, I was doing a whole bunch of profiling using NVIDIA Insight, and I said do update always equal to true, so I'm going to go ahead and disable that and redo this. Now it will be much less aggressive in re-rendering the scene. So let's zoom in, see, it's re-rendering the GUI every single time. So if I click this, look at that. It selects all of them, but it doesn't change anything. I wonder if this is really just a rendering issue. I think it might be. Okay, let's set our far plane to 2. Set our far plane back to 1. What happens if we set our far plane to 0.5? Still not that great. Not that great. And now, okay. Yeah, it's not rendering as much. Okay, so that is not quite the panacea I was hoping for. Let's go ahead and get rid of our issues there. I'm actually just going to take a quick look at the diff for simple GUI. Yeah, we'll snag this. Put this, I'm going to revert this part. Then this part, I'm going to get rid of the end group because we didn't use a group. And this part I am going to stage. Piglet context, I've got it set to a different OpenGL. I'm actually not going to commit that right now. So where we're at is basically, I don't think that I know the right way to fix this rendering issue without doing a fair bit more digging. So let's take a look at our stage changes here. Ugh, thought I didn't want to stage this. Let's unstage it. Okay. So now let's take a look at Simple GUI. Yeah, that's the version that we want to stage. Okay. Revert. Okay, let's unstage everything. Boy. Alright, let's go back here. Go to Simple GUI. See what we've got. So the clipping plane doesn't seem to really do it. Although I think it should. I think our best bet is still going to be figuring out how to not allow gigantic particle renderings through triangle strips to overlap. And I think we could do that through an algorithmic change, but I still want to figure out if we can do this a little bit simpler here. Now, when I did my profiling, I wasn't able to get shader performance, but the fact is that even when I do a completely flat shader, it gets bogged down quite a lot. And I really don't think that there's a way to get around this where essentially we're having to render lots of really big quads. So each one of these, and you can see what happens as I restrict the size. But the fact of the matter is that that's not really physical, because each one of these particles really does need to have an extent that's reasonably large. And so an algorithmic change could help get us around this, but I don't know quite the right way to implement that algorithmic change. But on the plus side, we do have some new additions to the camera plane. Alright, so let's finish this up a little bit. As long as I'm doing this, I'm going to go ahead and unroll this just in case it's where the issues are coming in. So we're going to say array, we're going to say position equals scene.camera.position, copy, say scene.camera.position. Here we're going to say camera position. position changed for that. Set attribute. We will actually just say scene.camera.position equals np.array of values. And here, I'm going to say format equals %0.4f. This will be position. What were the three items? I think it was focus and up. So position, up, and focus. So up, camera up, and this time it'll be focus. Input float 3, focus 0, focus 1, focus 2. And then down here, scene.camera, near plane, far plane, now let's take a look at this. See if this got rid of our over selection issue. No, it didn't. That's kind of frustrating. Interestingly, position and up are oh yeah, of course. So it must somehow be retaining a reference or something, and it thinks that when I click on that, it needs to be on all of them. Okay. Well, at this point, I'm going to have to sign off. This was a frustrating end. I didn't really get done what I wanted to, but let's take a look at our changes. Simple GUI. Yeah, I've unrolled all this. Piglet context. Don't need to commit that. I think that's everything we want. So let's commit. We'll push up to our pull request. And that is that. See you all soon, hopefully.